is related with, it is a branch of spectroscopy and which giving us information about the atomic absorption. So atomic absorption spectroscopy, today we are going to discuss this topic. Next slide. If you see the spectroscopy is the general term for the science that deals with the interactions of various types of radiation with the matter. Okay, so what is the term important there? The matter and interactions of radiation. So we come to know that spectroscopy is the general term which include the interactions of various types of radiation with the matter. So matter is very important. If you see over here, spectroscopy is divided in such a way. First one, atomic spectroscopy and molecular spectroscopy. Now this atomic spectroscopy is again divided in two types, AAS and AES. So this AAS, flame absorption spectroscopy, and over here flame emission spectroscopy. E for emission and A for absorption. Now molecular spectroscopy, again it is divided into MAS and MES. In this category there are two terminology, UV, SIR and NMR, and here fluorometry. In this way spectroscopy is divided. In today's lecture we are discussing with the AS. Now see, here in last chart we have seen atomic spectroscopy and molecular spectroscopy. Atomic spectroscopy deals with the interactions of electromagnetic radiation with the atomic spaces. And if you see here, molecular spectroscopy deals with interactions of electromagnetic radiation with the molecular spaces. Here atomic spaces for atomic spectroscopy, here molecular spaces for molecular spectroscopy. In this way it is divided into two types. Okay, the electromagnetic radiation and electromagnetic radiation is same in the both terms. There is only one change, that is the atomic spaces and molecular spaces. Next one. Now what is the history of this AS technology? The first atomic absorption spectrometer was built by CSIRO scientist Alan Walsh in 1954. Shown in the figure. Alan Walsh is on the left hand side with the spectrophotometer. If you see the diagram, first introduction of this technique in 1954. So when we study the different aspect, different terminology, we must know who was the founder of that terminology. Otherwise what will happen? We don't know what type of this process, who was the founder of this technique. In every times we have to think about this. We have to learn anything from starting to end. So we must know what is the history about that terminology. Next point. Atomic absorption spectroscopy, AS, is the spectroanalytical procedure for quantitative determination of chemical element using absorption of optical radiation by free atoms in the gaseous state. Here we come to know that what is the important quantitative determination of chemical element. About this AS technique is used for more than 70 elements, or we can say up to the 70 elements. Up to the 70 element, this technique is useful. Up to the 70 element, determination of 70 elements, this technique is very useful. Here again see the determination of chemical element using the absorption of optical radiation, that is the light. So here there must be a source by the free atom in the gaseous state. Atomic absorption spectroscopy is based on absorption of light by free metallic ion. In analytical chemistry, the technique is used to determine the concentration of particular element. When you see the different applications of this AS technique, then you come to know that by some plotting graph, you must know how the concentration of particular element can be determined from the sample. When you analyze the sample, you can find out the concentration of particular element. AS can be used to determine over 70 different elements in the solution or directly in the solid sample via electrothermal vaporization. Now the principle. The atoms of sample in the gaseous state absorb the energy. They shift from ground state to the excited. You know that what is there? The atom of sample in gaseous state absorb the energy. The light coming from the source is absorbed by that sample, and due to this absorption, the gaseous state absorb energy, and there is a shift from ground state to the excited state. We know that when any atom absorbs the energy, it is shifting from ground state to the excited state. Same way, here there is a absorption takes place. Here, sample should be atomized, and atomization is a critical step which affect the precision. In this technique, now see there, here sample should be atomized. Sample should be atomized, okay? In liquid state to the atom state or free state, it must be there. And this step is very critical. If this step get fails, your precision also get fails. You will not get a proper results. So for that purpose, the atomization process is very important. Now if you see over here, take a solution sample. Nebulization means small droplet. There must be a small droplets, and there is a spray of the small droplet. There is a dissolution, dry aerosol, volatilization, free atoms and molecules and ions. In this way, your sample solution get converted into the free atoms. Okay, by these three steps. Okay, first one, see here, your sample solution. Nebulization means small droplet formation takes place. Thereafter, dissolution, and thereafter volatilization. Volatilization means you get the free atoms. So this is the process of atomization. If this process get failed, you will not get a proper or accurate answers. Okay, see here, process of occurring during the atomization. So this step is very important to get accurate result and to identify the element and their determination of concentration. If you see the instrumentation of atomic absorption spectroscopy, you come to know that here, see here, a radiation source. Here is the radiation source. Thereafter, chopper. Here, chopper. Thereafter, atomizer, sample, and there all the things containing the atomizer. Nebulization of liquid, sample, monochromator, detectors, and readout device. Okay, these terms are very important. If you do not have a proper radiation source, you will not get the proper answer. Chopper required every time in this AS techniques. Atomizers, nebulization of liquid sample, monochromator. Now say there are, you know the types of monochromator. Which are they? What are the different types of monochromator? What are the different types of monochromator? What is monochromator? Conversion of polychromatic light into the monochromatic light. Okay, single wavelength light. There is conversion of single wavelength light. Okay, so monochromator plays an important role, as well as you know the detector also. What are the different detectors? Photocell, photomultiplier tube, then phototube, photomultiplier tube, then one more, thermal conductivity detector. Okay, these are the few detectors, but here phototube, photomultiplier tube can be used. Okay, now nebulization of liquid. See here, due to the radiation source, the liquid sample coming from this nebulization. Okay, here nebulization process takes place, which is carried to the wavelength detector, and lastly single process readout device. When we come to know that what are the answers. Okay, so this technique is very important. Its instrumentation is also important. Next point. Now schematic diagram of AS. See here, you know the hollow cathode lamp. Okay, you have a question about this hollow cathode lamp. Many times this question asked in the exam about the hollow cathode lamp. Write down the note on hollow cathode lamp. Here hollow cathode lamp. Here nebulizer. This nebulizer. Test solution here, and there is a flame. Here is a flame. Okay. Thereafter this monochromator, detector. Lastly data processor. Through this data processor we come to know that what is the answer. Okay. See the system. This is the hollow cathode lamp, radiation source. Thereafter here is a flame. This is a nebulizer. Okay. From nebulizer, the test solution coming to the nebulizer, and there is burning of gas takes place. Okay, with the sample, with the test solution. Okay, and after burning, what is the answer? Going to the monochromator, and monochromator to detector. Detector is detecting what type of radiations coming towards itself, and from that detection we come to know that what is the answer in this data processor. Next. Now radiation source. Now what is the criteria of radiation source? Should emit stable and intense radiation. Should emit stable and intense radiation. What does it mean? Stable means you require a continuous radiation. If there is a fluctuation, then it must affect your analysis. Okay, there must be a continuous radiation source. For that purpose, we can use a DC source, that is the direct current. Otherwise, if you use the AC current, it may be fluctuation takes place and it will affect your radiation. So, should emit the stable and intense radiation. Intensity should be corrected when in proper one. Here, hollow cathode lamp, electrodeless discharge lamp. Now see this lamp, glass sheet, over here a glass sheet. Here, discharge lamp anode. Here, hollow cathode lamp. Here, quartz Pyrex window, neon or argon at 1 to 5 atmospheric pressure. Okay, so in this tube there must be a pressure of neon and argon about 1 to 5 gaseous pressure. Here is a gas sheet, here is a hollow cathode, and there is a quartz Pyrex window. See here, its original figure over here. Radiation source.
Neon
or argon at 1 to 5 atmospheric pressure, 1 to 5 pressure. 1 to 5 means it is with unit of pressure. Okay. Then next, hollow cathode lamp. Actual diagram. See here, Pyrex body of a glass. Its upper part cathode. Here is cathode. Okay. Here anode, Pyrex body, and above that there is quartz window, which look like a glass. Okay. Then chopper. In our instrumentation part, we have seen after radiation source there is a chopper. Okay. What is the role of chopper? A rotating wheel placed in between the lamp and flame is known as a chopper. Very simple. There is a wheel which is rotating. In between radiation source and lamp and flame. Okay, there is one chopper in flame and lamp. In between that there is chopper continuous. It is a rotating light getting cut and off. It is used to break the steady light from the lamp into the intermittent or pulsing light. Means what? If see there, wheel is rotating, light get cut on. In this way, light is coming, and it means off and on. In this way, you are getting a light due to the chopper. Next point, atomizer, flame atomizer, electrothermal atomizer, flame atomizer, total consumption burner, and premix laminar flow burner. You know that there are two types of burner. Okay, there is a total consumption burner and premix or laminar flow burner. Now types of flames: fuel oxidant, acetylene, acetylene, N2. Now see the fuel oxidant picture. This is the primary combustion zone, secondary combustion zone, and intrazonal region. When flame grow, the flame look like this. When there is a grow of flame, it will be look like this. How? This is the internal part, that is the primary combustion zone. This is the secondary combustion zone, and this is the intrazonal region between these two zones, primary and secondary. Now see, intrazonal region is the hottest part of the flame and the best part atomic absorption. This part of the flame, when you carry any experiment at that time, the upper part have a power as compared to the lower part of the flame. So this intrazonal part have a highest capacity for atomic absorption. Second, oxidation of atoms occurs in the secondary combustion zone, where the atoms will form molecular oxides and are dispersed into the surrounding. Next. Now this is flame atomizer, laminar flow burner. This assembly, actual assembly is like this. This is a here, flow spoiler retainer screw over here, auxiliary oxidant, fuel, nebulizer adjusting knob, sample capillary here, There is a nebulizer. To west, nebulizer, oxidant, flame spoiler, pressure relief vent over here, burner head, locking ring here. This ring will be moving, and the burner head over here. You will see the flame. So actual assembly is like this. Actual assembly is like this. There are these parts, these types of parts are there, and we will see the flame above this part. That is the burner head. Okay. Next one. Now see here again, electrothermal atomizer. Second type of atomizer. Next, nebulization of the liquid sample. Before the liquid sample enters into the burner, it first of all converts into the small droplets, and this method, formation of small droplet from liquid sample, is called as a nebulization. Now see here, before liquid sample enter into the burner, before reaching to the burner, it gets converted into the small droplets, and that process is called as a nebulization. This question may be asked in the exam for 1 mark. What is nebulization? Conversion of liquid into the small droplets. Conversion of liquids into the small droplets. Which liquid? Sample solution. Or sample solution or test solution. There is conversion into the small droplet, which is called as a nebulization. Now here, a common method of nebulization is by use of gas moving at high velocity, called pneumatic nebulization. Okay, that is the pneumatic nebulization. Now monochromator. Here, as commonly used monochromator are prism and grating. So in last few minutes before, I asked you question, what are the different types of monochromator? So there is a prism and grating. So grating is like a bruise. It have a different bruise, and you know the prism. You have seen the prism. Okay. So these two terms are as a monochromator. And detector, photomultiplier tube. Photomultiplier tube. I had tell the two examples before few minutes. Okay. So in this technique, AS technique, a good detector is, that is the photomultiplier tube. Next point. Now see here, lamp, flame, monochromator. Here is a prism, not grating. Here is a prism. Detector. Okay. In this way, the sequence is there. Here, atomic emission. Okay. Now, flame or plasma, monochromator and detector. In this way, you can judge what type of A is this. Next. Now, general principle of flame photometry. What are the general principles? When liquid sample containing metallic salt solution introduced into the flame, the following step takes place. Now, it's very easy. What we have seen. First one, radiation source, then chopper, then flame, then monochromator, then detector, and then radon level. 6 points we have seen. Okay. In that, in every point, what is there we have seen. Now, if we see here, what is happening? Second point, that is the nebulization process takes place. Nebulization. Sample coming into the burner head to above, and there is a burning of that gas as well as that sample. Now, what is there? When liquid sample containing metallic salt introduced into the flame. Okay. So our liquid sample having a metallic salt. What is happening there? First step, evaporation of solvent, leaving particles of solid salt. Okay. Your sample containing metallic salt. Okay. That's so that the solvent get evaporated. And what is remaining? That is the salt. In second step, that salt is vaporized or converted into the gas state. What is happening there? Salt is vaporized or converted into the gas state. Okay. Third point, dissociation of all gaseous molecules to give neutral atoms or radicals. Fourth step, formation of excited atoms. Formation of excited atoms and emission of radiation from the atoms, and measurement of wavelength and intensity of emitted radiation. These 5 steps going to be happen when the sample introduced into the flame. Okay. Next point. Application of AS. AS mostly powerful instrument technique for the quantitative determination of trace metals in the liquids. Okay, that is the most important. Metallic element in biological material also. It is used in multi-component analysis also. Metallic impurity in food industry. Calcium, magnesium, sodium, potassium in blood serum also. Okay. Next. determination of lead in petrol. Flame photometry has been used for determination of element. These elements boron in various type of organic compound and is used natural and industrial, water, glass, cement, petroleum, metallurgical industry. So AS has a wide applications. Okay, this is the instrument of AS. It looks like this, and on this you have to perform any practical or any work related with AS. Next, thank you.
Stop बटन
पावर सेव
सर ती स्टॉपच आहे ना डिलीटची बादली इथं नाही रे इथं आधी स्टॉप करायची नाही ना थांबतच नाही कुठं